Hello, fellow teachers. As we've seen in this course, it is impossible to imagine society today without AI. In order to enable students as future citizens to responsibly participate in and create this digital world, everyone needs a basic knowledge of AI.
The goal of AI education is to enable people to participate in an increasingly digital world by using it consciously and to see how it affects them personally. Furthermore, they should get involved in shaping this world. A foundational knowledge about AI enables people to not only use applications of artificial intelligence, but also to design and create their own AI solutions. And with an increasingly important debate about the ethical implications of AI, the goal is also to make informed decisions about AI in society. While there's no doubt whether or not we should teach AI, the more interesting question is what to teach. Which topics are relevant for students to learn, whether or not they will become computer scientists? What knowledge is required for their futures? For example, to make informed decisions about AI. Let's do a simple experiment. Please try to remember the alphabet provided on the right-hand side within the next 30 seconds. Alright, your 30 seconds are up. Can you translate these four symbols into numbers? Well, it was 1, 3, 3, 7. Does this match your solution? You may find this task extremely difficult. And you might ask why on earth you would need to learn that. Actually, the encoding is inspired by telephone dial keys. The 1 is encoded as a border to the right and bottom, the 5 is a complete square, and the 8 is surrounded by borders everywhere except on the bottom. You get the idea. While remembering the whole alphabet within 30 seconds is very hard and difficult to learn, and rather pointless, it's actually rather easy if I understand the dial key idea and the underlying principle of the encoding. If we made you learn the underlying principle instead of the full encoding table, you would have been able to decode 1337 much easier. And, in fact, you might recall this encoding for the rest of your life. What can we learn from this experiment? In teaching, we have to focus on the underlying ideas as well, and not just on the certain applications for a topic.
Applying this to AI education means that we should favor understanding the underlying principles, such as how machines can learn, rather than just the usage or application of certain frameworks like TensorFlow or PyTorch. Furthermore, it is more important to let the students create personally meaningful artifacts, as the students learn best while being creative and pursuing their own goals, instead of using predefined models for somewhat artificial projects. In addition, only a look at the underlying principles will enable students to discuss the topic of AI in a differentiated, unconscious manner, as opposed to being part of a one-sided debate by either solely focusing on hyping the potential or exaggerating the societal risks of AI. In this course, you've seen some teaching materials that you might use directly in your classroom. Our first approach to AI and machine learning was always using unplugged activities. We also utilized Snap, the programming environment for learners, to introduce you to some of the underlying magic of machine learning algorithms. With AI Unplugged, we provide you materials to literally pull the plug on artificial intelligence. Without using computers, these activities help students to get a feeling of the underlying principles and the ideas of artificial intelligence. With the materials provided on AIunplugged.org, you'll be able to play the Good Monkey and Bad Monkey game that was about classification with decision trees and supervised learning. You'll also find the activities regarding the simple chessboard game Beat the Crocodiles that introduced you to the difference between reinforcement learning and traditional or symbolic AI. Two additional activities allow students to mimic the workings of a neural network for image recognition or replay the Turing test we spoke about at the beginning of this week. All material is also available for printing. We then can replug those activities, for example with Orange 3. Orange is a tool that allows you to train, see and use ML models without the need to code a program. Now you can use the examples that you've been working on in the unplugged versions to explore how those fancy algorithms work inside a computer. You can find more details on the material at computingeducation.de. What we are missing so far is the look behind the scenes. Meanwhile, there are a variety of pedagogical frameworks to introduce students to ML programming, but the actual learning takes place using pre-trained models or through external servers. The actual learning process is neither in the focus nor visible to the learner. This is where Snape kicks in. It breaks open the black box by offering hands-on experience on ML algorithms within Snap. Snape includes activities for all types of machine learning, like the Gold Rush task or the possibility to pimp your own games. You might remember the Banana Hunt game from week 1 that taught you about reinforcement learning. All programming activities we've used in this course can be found at snape.org.
Now we have explored many examples of how to incorporate AI into your teaching. And of course, you can also use the course videos themselves in your classroom. Since links and materials might change over time, we've provided you with a list of further inspiration in the additional course materials. This includes links to materials like Machine Learning for Kids, eCraft to Learn, and many more. Feel free to check them out. So, thank you for joining us on our journey through the world of AI. We hope you got some exciting new insights on what AI is, how machines learn, or if machines can think. However, this is not the end. If you want to stay tuned, get in touch with us. For example, via mail or Twitter, or check out computingeducation.de, where we will happily share our new ideas about artificial intelligence, machine learning, and computer science in education with you.
Thank you for traveling with us. We hope we'll see you soon on our next journey through the fascinating world of computing.